Hi, 131. In this tutorial, we'll be working on how you can make your Pavilion Precedent into a 3D model in Rhino. So as you recall last quarter, you also received a Pavilion Precedent project, but in that case, you used it to make a 2D oblique drawing. But in this case, we're going to use some same techniques, specifically in laying out your drawings in a way that you can use to help guide you to make a 3D model with the knowledge that you have from your most recent assignment on your introduction to using Rhino as a 3D software tool. And so with that, in this tutorial, I'll be using Kenyo Kuma's Nest Regrow Pavilion as he worked on with UC Berkeley students as an example of this tutorial. And this is an interesting pavilion to study because it examines what structural members could be, what structural members could be combined to make a community and food-oriented space. And so as we move on in this tutorial, we're not going to be necessarily focused on the nitty-gritty details of the pavilion, like where these nuts and bolts might be located, but rather onto abstract materials as shape and the material and experiential textures of these materials. And so as we look at this pavilion in more detail, this wooden pavilion to be exact, we notice that this pavilion is built out of several wooden members. So for example, in this column, it's comprised of multiple wooden members that are intersected by this beam that is also notched within this column itself, right? And so we'll be using this to investigate different kinds of conditions and how they're treated within the pavilion and your pavilion too. And so this can mean like a floor to wall type of condition, or a wall to a ceiling type of condition, or a wall to ground type of condition. And so with this detailed investigation, it can show to us how the treatment of the materials in these kind of different layers of, or these different conditions, of lack of a better word, are treated and how they add on to the overall effect and experiential qualities of the pavilion of our project altogether. And this can also inform us onto our future projects in our curriculum too. So as we build this pavilion and the investigation that we're going to do, in this tutorial, I'm going to be focused on the floor to wall condition. So in this case, I'm specifically focused on this 6x6 area on the 4th floor, meeting this exterior wall. And so to make this 3D model of this pavilion and this area specifically, I had to use the ground floor plan, the AA section that they provided, the 4th floor level plan, and also a detailed and a large detail drawing of the AA section that's over here. And so to begin with, we have to begin by placing a drawing into Rhino itself, right? And so we can do this by using the picture command. And so I'm just going to pull in some floor plan. And so I'm just going to randomly put this into whatever size first. And so when I put this in, I notice that first, this drawing is scaled to millimeters. And I'm going to be building this model in imperial units, specifically in feet. And we need to scale this down accordingly, or to scale this upwards. And so just by doing this on several trial runs, I know that there are approximately 305 millimeters in a foot. And so I can just insert that into Rhino itself as an equation. So I will make a line as a reference from this end of the scale and type in at 2000 divided by 305, comma 0. And so this is just going to immediately give me that Cartesian coordinate in the x direction of what 2000 millimeters is in feet units. So I'm just going to go ahead and type in scale and then go at the edge of this line that I just created to the edge of the scale. And I want to make sure that my snapping is on. So I have this reference line that you see here. So I can toggle it into a perfect horizontal line and scale it accordingly. So I'm just going to scale this down to the line that I just created, the end of the line that I just created. And now that I've scaled it, I know that this floor plan now is scaled to the feet units that I'm going to be using to model the project altogether, right? So once you go ahead and pull in your relevant drawings that you need to build your project, you can go ahead and model your project in Rhino, right? So the way that I've laid out these drawings in Rhino is like so, because I wanted to align all these drawings together. And so if you notice, I have, let's take this line, for example. So this is called a grid line. And so you can identify this by, usually it's bubble annotation. So this is a 4, and there's a line that goes from this 4 all the way through the drawing. And if you take a construction line and draw a line from the tip of this 4 all the way to the bottom drawing that I've included, you'll notice that all of these grid lines align together. And now that I am sure that all these drawings line up together, I can try to go ahead and make or map out the boundary of where I want to build this model from, right? So again, this is going to be a 6 by 6 foot model in Rhino. And I'm going to go ahead and start with the 4th floor level plan. And in trying to map out like the area that I want to map out, I know that I wanted to map out this floor to edge of the wall condition, right? But in this 4th floor plan, there is no indication of where this section line is taken at. So I don't really know where it really is. I kind of know that it's on this right side, but I'm not sure where on this right side. So the only indication, or the only obvious indication of where this section is being taken at, is only at the ground level plan that I've been taking at. So I know this because it's denoted by these section flags that point towards this direction, this east-western direction. And so I'm just going to draw a horizontal line as a reference, and then copy it into the 4th floor plan. And I can do this because I know that when I was given this floor plan, it is in the same image size, and also it is in the same scale of each other. And so I can just use a copy to simply just copy this and use that as a reference for the 4th floor plan. So now that I've noted the section line, this is around the area that I want to build my area off of. So I'm just going to go ahead and draw a 6 by 6 box, and I'm just going to type in at 6 by 6, and I'll just move this according to its center to, oh, I have to make sure that the center toggle is snapped on, or the center button is toggled so I can snap to it. And then I'll just move this to the area that I want to be drawing in towards. So now this is 3 feet after the section line, and also 3 feet before the section line. So this is a 6 by 6 area of approximately the area that I want to build out. So now that I've noted the boundaries in the floor plan, I also want to denote the boundaries in the section. And I'm just going to use the detail plan, or the detail drawing, to get a better sense of the section, because it's kind of enlarged, and it also is just easier to just go up and down for me. So I'm just going to take a line and extend it all the way upwards on either ends of this section, or this boundary. And first, I'm just going to change this boundary box into the layer that I've designated it for. just so that I can see it better. And then one thing to note about this section drawing is that these floors are measured by these dotted lines. So if you see these flags that call out plus 6.958, that is where in this case, the fourth floor is considered to be. So it's considered to be at the top of these planks of the catwalk. So you see these catwalk, it's measured over there. So it's being measured at the top of the plank of this catwalk. And so this is where it's considered to be the fourth floor. And so since we're making a 6 by 6 by 6 inch or 6 by 6 by 6 foot area of this 3D model or volume, if you will, I'm just gonna make approximately 2 feet down, and then I'll just go up by 6. And so this is the area that we're going to be building. And now I'll denote that with the boundary box that I'll create. So now we've mapped out both of the areas that we're going to be building in both the detail drawing and the floor plan. And so with that, we can also go ahead and start actually building. So the first thing I want to do is start with the section drawing. And I think this is going to be the easiest part or easiest way to start in your model, because for the most part, we're going to be building our model according to the x-axis, because if we extrude, and this will be easier seen through the perspective view, but if we build our model in this direction from the section drawing, we're going to be extruding it this way in the Z direction, if you will. But if we build it on the floor plan, we'll be building it according to the X plane in the as a floor plan, if that makes sense. And you'll see as we continue to go along in this tutorial. But for now, I'm just going to go ahead and zoom back into the detail drawing. And one thing that I also noticed in these detail drawings, and also there are some in the floor plan, but if your floor plan doesn't have like a poche or anything, one thing that they do to denote a section cut is with these X's. And so this is kind of faint, and you can see it more clearly here. But these X's show a cut element or a cut component. So this curve has it, this curve has it, this one, this one, this one, this one, this one, this one, this one. And there are other ones that are in this detail drawing that have it too. So if we double check, let's say we take this one, for example, this cut element, and we translate it back into the floor plan, where this is our section line, that beam right here is evident here. And this is definitely cut by the section line. So that checks out. And so that's how you kind of double check how those lines are also cut too, and make sure clear, like concise or definitively that those are actually cut elements. So I'm gonna go back and start modeling model. So I'm gonna go into the model layer that I've set, and then I'm gonna use the rectangle command to just outline the section. And I'm doing it so like this. And I'm just going to change this to a different color so I can see this more clearly. I'll go with blue, or I guess cyan. So now that I have that out, I can just copy this to this other side, knowing that these beams should be the same. And then I'll also just outline it over here too, knowing that this should be on the same plane or on the same kind of height, these bases. And then I'll also copy this to the other side. So now that I've mapped at least these portions out, I can go ahead and just start translating this into the floor plan. And so from now, I'm just gonna do a lot of translation, and you're gonna do a lot of translation and drawing between these two drawings. And so how I'm gonna do this is by hopping into the perspective view, and then I'll zoom into the area that I've just built out. And so just to do this more quickly, I'm just gonna type in ZS, zoom selected, and this is gonna automatically zoom my camera to the areas that I've selected and also reset my camera to zoom to the area that I've selected. And so in doing this, I'm just gonna rotate this 90 degrees. And then I'm going to move or copy these elements, these rotated elements, into this floor plan so that I can extrude it in this XY direction, if you will, or at least in the Y direction. So I'm just going to take these elements and then copy them so that they are in the same location that I want it to be. And so one thing that you have to be sure to note is that your snapping is on. And so what I'm going to try to do is just align it along this line so that it just meets the section line. And then I'm just going to extrude it from there. So once I see the perpendicular snap, I'm just going to copy to there, and I'll start extruding from here. So I'll just type in extrude curve command, and then I'm going to make sure that solid is turned to yes. And then for now, I'm just going to leave both sides for no. But if your extrusion is completely symmetrical, then you can leave it on. And so this is what it'll look like if you wanted to extrude in both sides. But for now, I'm just going to leave that to no. And I'll just do it one by one for now. So I'm just going to extrude this to the extent of my boundary on both sides. And the reason why I'm doing this in two parts is because I'm not entirely sure if this is, or at least my cut that I made is fully symmetrical. I think it is, but I think I'm just doing this out of caution. So I'm just going to go ahead and just Boolean union this just to make it all clean, and then merge all coplanar surfaces so they're cleaner too. So now that I have built my first two components, these two beams, and this is the bottom of the catwalk. So if you go back to the detail drawing, we see that these beams rest below the catwalk planks. And so now we can start going ahead, just make the planks of this catwalk. And we remember that the floor is considered to be the top of this catwalk. So we can just simply make a rectangle that goes up to the extent of that, reference line that we just made before, or not too long ago. And so I'm just gonna go back to perspective and then zoom back to the area that I just created for the catwalk, that plank. And again, with the same process, rotate this 90 degrees. And then I'm just gonna copy this to the top of the beams that I just made on the floor plan drawing. So I'm just gonna zoom back and then zoom into the area that I just made. And then I'm just gonna start and extrude this. So I'm gonna go into the top view again, because I think this is gonna help me in making at least the planks of the catwalk, at least more accurately. So I'm just typing extrude curve again. And I'm just gonna go all the way to about here, because I think that's where plank ends. And I've just made one plank. So now when I go back here, you can tell that it is certainly a plank. So I'm going to copy this to the end so they meet each other. But I remember that from the photos that we're taking of this pavilion, there seems to be spacing between the planks, between each planks. And because this assignment is mostly focused on the material effects of the pavilion, we're going to have to build this according to or to preserve the material effect of the pavilion itself, right? So what I'm going to assume for now, for the purpose of this tutorial, is that there is a 1/4 of an inch spacing between them. And so that is going to, in my drawing, when I do it later on, make sure that there is a gap between them to preserve the realism that is, or to preserve what is actually represented in the built version of this pavilion. So I'm going to go back to perspective and then copy this through the beam. And so I can just do this by copy, with the copy command, and then just keep copying this through the rest of it. So I'm doing it like so. And so now that I have kind of an excess, I'll just take this off. And for the purpose of this tutorial, I'll just extend this slightly so that it extends to the end of this, just so that it's a little bit neater. And just for the sake of the tutorial, when we go on to make the drawing of this too. So now we just made the catwalk, and we're going to do the same process for the rest of the 2 beams that we made up there, or that we mapped out up there. So in the same way, I'm going to go ahead and rotate these pieces. And I'm going to go back to perspective actually, and zoom select this again, and let's rotate this 90 degrees. And so one thing to note is that this was rotated about its axis in the middle of the rectangle, if that makes sense, right? And this was rotated about its own middle axis. And so if we turn off this picture, this is then set below this rectangle, this beam, if that makes sense, right? And so we know that with the detail drawing, that these beams rest at the same height. And so what we're going to do to account for this is make an intersection that will guide us in this drawing. So what I'm going to do is, actually, I think I'll do that afterwards. So I'm just going to move this to the floor plan for now, for the sake of continuity. So I'm just going to copy this using the same process that we did for the previous beams and the catwalk. I'm just going to copy this to the floor plan, making sure that the snapping is on so that I can have the reference, so I could align it straight down. So I'm just going to copy this right to here. And I'm going to zoom select because zooming in this is way off. So I'm just going to start by extruding it just like we did with these beams all the way to the edge here, or the boundary that I set. And then I'm going to turn off the picture to help me see this better. And so now that I see more clearly that these are at different heights, where they should be at the same height, at least the bottom parts of these beams. So one way to adjust for this is by moving, or I guess doing this in parts. So I'm just going to move the catwalk just above slightly so that it is right along the boundary box that we've made, that we established, right? So I'm just going to move this up slightly And then I'm just going to move these beams slightly upwards too. And so now they're at the same height, at least the bottom parts of these beams. And so we can ignore these later on, but I'll do that later. But for now that we change these, the heights, they're accurate to how they're supposed to be drawn. And we'll go ahead and keep continuing to work on this horizontal beam. And so one thing that we can do is go back into the detail drawing and top view. And we notice that this beam is just right along here. So I'm just going to make an outline of this section drawing of at least a beam and aft. And then I'll do the same process by rotating this rectangle 90 degrees. And then I'll just move this accordingly into the floor plan. So it seems like it'll be more accurate if I went to the top view to copy this. So I'm just going to copy this here. And I'll also extrude it from here too. So once I've kind of mapped out that outline, I'm also going to copy this again from the top view because I think that's a bit accurate in this case. And I'm just going to turn off the center snap for now. And now I have my two columns, or two beams, sorry, that rest on top of each other. Or at least the catwalk, the beams that rest on this beam. And so now I'm going to go ahead and make the columns that are cut vertically. So one thing that is similar to the detail drawing is that in the floor plan drawing, it doesn't have any approche as well. So because it doesn't have any approaches, there are these X's again that symbolize the members that are being cut. So all of these columns are being cut in this floor plan, and along with these smaller framing elements that consist of the exterior wall, right? And so for now, we're going to be making this column in the middle right here within our boundary that we're making. So what I'm going to do really simply is that because I know that this column is wrapped around by these beams that go from the east-west and the north-south directions, I'm just going to make an educated guess that I can just extrude it from this intersection in here, this area right there. So I'm just going to take the rectangle tool and just snap it to these intersections and extrude it just by that. So I'm just going to go ahead with the extrude curve tool or command, and then snap it to at least the top of here. And then from here, I'll just like go ahead and extrude higher. So I know that my boundary box is a 6 by 6 by 6 feet cube. So the top I designated before to be a 4-foot height, and then the bottom was to be at a 2-foot depth, or a 2-foot like lower kind of height thing. So I'm just gonna delete that interior thing, and now I have my column. I'm just gonna Boolean union this. At least I guess I can scale this so that it's just one piece. So this is going to help us afterwards too in our drawing, just to make things less cluttered. And so now we have our beams, our catwalk, and our column. And so we still have several stuff that we need to do to complete this drawing, like our exterior wall pieces, and also some elements that still have been cut and that we can put in this drawing too. And so we'll take a cut for now, and I'll come back to some further details that I can point out in making this 3D model of the Pavilion project that I have that specifically highlight the material details of this pavilion. Okay, so now that I finished making all the framing members and all the little details that consist this area, we're gonna finish this off by making the final portion of this 3D model, which is, in this case, I left the exterior wall to be completed last. And so one thing that I noticed for the wall, at least, especially materially, one thing it's important to notice in this pavilion is that the wall is made out of corrugated decking. And they denoted this in a call out here that it's a transparent corrugated panel. And this is not pointed out elsewhere. Actually, it's also pointed out here. It's still a translucent corrugated panel for the exterior envelope. And so, since this is a project that is, again, focused on the material quality of the pavilion, the way that we're gonna make this corrugation is kind of by assumption, because we want to preserve that there is this corrugated quality to the exterior of this pavilion. We should model that. And so what I'm gonna do is that, actually at first, we have to know that the corrugation itself is something like this. It's this sawtooth kind of shape on a corrugated panel like this, and we're gonna model that in Rhino too. So what I'm gonna do is I'm gonna start by putting onto these main cladding framing, and this is like regularly spaced out between these frame posts, if you will. And so I'm just going to build it on this face first. And for the purposes of this tutorial, I'm just going to assume that this is going to be maybe an 1/8 inch corrugation. So I'm going to start by typing at 1/8 of an inch, comma 0. And then I'm just going to continue this. I think this is, yeah. And then -1/8 of an inch. Actually, I think this is relatively small. I'm just going to bump this up to 1/4 inch. Sorry about that. So I'm going to type in 1/4 of an inch, comma 0, maybe 1/2 an inch, comma 0, and then 0, comma -1/2 an inch. Let me redo that. So I'm going to start from the middle from here. So 1/2 an inch, comma 0, and then 0, -1/2 inch, and then 0, -1/2, comma 0, and then I'm going to keep going with this pattern. once I have this out at least, I'm gonna pull it out for a bit so I can see it better. I'm gonna keep copying it. I'm gonna keep copying it until I meet this middle here, and then I'll just trim it. And I guess in this case, it's not trimming. And I noticed that apparent intersections is on. So, oh, I guess I just enjoy it. So I'm just gonna go ahead and start joining all these together, all these different segments together. And then from here, I'm just gonna move this back onto the framing pieces, the framing elements, and I'll copy it like so. And I'll keep copying it to these ends as well. And then I'll also trim these off, the excess. And now I have at least 1, 2, 3, 4 panels of these that I need to extrude. And I'm just gonna zoom select this again. And I'm gonna turn off the picture layer. Actually, I'm gonna turn it back on just as a reference. But I know that these corrugation looks like it goes all the way down. And I'm just gonna treat this for the purpose of this tutorial that all these panels are one panel for, I guess, one frame, and that they go all the way down to this bottom part here. And so the way that I'm gonna do this is, for now, I'm just gonna turn this off. And then I'm gonna extrude this all the way to the bottom part of my boundary that I set. Again, it's a 2-foot drop downwards and a 4-foot drop upwards, right? So it's a 6 by 6 by 6 cube that I'm modeling. And so I'm just gonna go all the way down to the extent of that framing element right there. And then to include thickness, because currently this doesn't have thickness, I'm going to type in offset SRF. And then I'm gonna choose, I said 32nd of an inch thickness. And I'm just gonna press right click on it to enable it. And I think it's, yeah, so now it has been created. And now I have a corrugation on this outside. And on the inside, I have my model itself, where you have these beams and you have this catwalk and you have the different planks of the beams too. And so with that, now you can start going on and making making the make 2D of this in order to present this in your final project, right? So the way I'm going to do this for now is that there's several tricks in Rhino that can help you increase your efficiency to do this. So I'm just going to turn off curves, and then I'm going to have to make an interior view and also an exterior view of this, right? In 180 degrees. So it's going to be this view that I want to capture, and also this view. And the way that I want to look at this is by typing isometric. And let's experiment with which view. So I want to see this view, right? So I think the closest view to this is northwest. And ignoring the test runs I have, this is not exactly the view that I want. So I think it's northeast. No, it is southwest, I think. Yeah. So this is the interior view that I'm trying to make the 2D out of, right? So I'm just going to select this entire thing again and type in make 2D. And I want to make this from the parallel view, from the view that I'm looking at right now. And then I want to maintain it by output layers because we're going to manipulate that afterwards. And we want to keep these settings as they are. And I'm just going to title this interior. And then it's going to make 2D for us, the 2D drawing. And I'm just going to zoom out and just pull this drawing right next to us. Turning on curves back first. And then I'm just going to do the same to do the exterior view. So I think this exterior view is going to be the southwest or northeast. Yeah, this view. And so when I type in ZS again, zoom selected, I'm just going to zoom right into what I want to zoom into. And I'm just going to make a 2D of this part. So I'm going to title this exterior. And now I have my parallel drawing of the exterior of this wall to floor connection. So I'm going to turn curves back on. And then move this to where I want it to position to. And I'm just going to make sure that these are lined up. And one thing to know about Make 2D, you notice already, is that there are so many lines in here, and there are inconsistencies in this drawing because there are some lines, as you can see, that are not there. So this line is not there, and this vertical line of this corrugation is not there. And so what's happening is that in complex figures like the corrugation that we just made, it's not exactly going to be the most accurate. So one thing that you should be doing when you always make these Make 2Ds is cleaning any extraneous lines up, or adding any lines that need to be there too. So what I'm going to do is do a portion of the cleaning up on Make 2D, and also doing a bit of the line work as a way to guide you on how you can do these Make 2Ds altogether. So I'm just going to go ahead with the corrugation. And I guess one thing that I think might help is just to make this corrugation as a 2D thing, because I'm seeing a lot of inconsistencies in here. And I think one thing that is going to be helpful for, I guess, this part, because it's a very tiny part, because this Gabby, as you can see here, is supposed to be a thickness of it. But if you draw this out in Rhino and export into a PDF, it's going to be super dense, and it's going to appear as a thicker line width than it's supposed to be. So for clarity, I am going to delete these and just make this without a thickness. And so I'm just going to make 2D this again. I'll just isolate this first. Actually, I do not want to do that. But I'm just going to make, take the isometric view of this again by orienting my view correctly and making 2D again. And then I'll just drag this to where I want it to be. And I'll do the same for the interior too. But let's check on this first. So we can see already that this is a lot cleaner than this drawing up here, especially with these gaps that aren't there anymore. So when I'm going to do my line works, I'm just going to start cleaning up these parts. So there are some extraneous lines here that I'm going to clean up first, like so. And there are also these lines that keep going in too. The one thing that I'm going to do is I'll continue taking out these lines. But one thing that I like to think about in making these line weights for these isometric and parallel drawings is by considering line weights in this situation by the profile of the thing that I'm drawing, right? So what I mean by that is if I start making lines or making layers for these line weights, I'm just going to start with profile and then maybe go from there. So I'm just going to start from here now. So I'm just going to start with a 0.5 to delineate the profile of these drawing altogether. And what I mean by profile is that I'm just going to take the outline of the entire drawing itself and then delineating that first. So I'm just going to start here at least. So I don't really want to deal with that corrugation for now. So you see I'm selecting the profile of the perimeter, or at least the quote-unquote perimeter of this drawing, right? I'm just going to set it to the profile line weight. And then one thing that I'll have to do is then split this line into multiple segments so that I get the profile of it. So I'm just going to change these lines then into the profile, and then I'll keep going with the rest. So I'll just make a cut here and then come back when I have the entire profile line set. So now that I've called out the overall profile or perimeter line of this parallel drawing, I'm going to go ahead and make a new layer called the surface profile layer. And this surface profile is just going to call out the outline of an object that is separated aerially between, let's say, this beam, or I guess this column to this handrail, right? And so we know that these aren't really next to each other or near each other, right? So I'm just going to make this into a different layer, let's say blue, to call out its profile. And I'm just going to go ahead and do that for the rest of the things that are separated kind of aerially with each other, right? So I'm just going to go ahead and do that for the rest of these layers in the drawing. And then I'm just going to, again, cut back to a time when I'm done with these. Okay, so now that I finished with this surface profile layer, I'm just going to go ahead with this last line weight layer, which is going to be the line weight that's considered, that I will consider kind of the surface elements, if you will. And so this is going to be basically just dense items like this one, which can be considered to be like a more composite thing, and also these certain conditions where this is a convex surface on this entire block, and let's say a concave surface on this entire kind of shell too. And so what I'm going to do now is just simply change this to yellow, let's say, or actually, let's say gold, because yellow is a little bit hard to see. So I'm just going to lock up these layers, and I'm just going to select everything else, and then change it into this surface profile layer. And so once I do that, I can also assign these line weights to what I want them to be. So I'm just going to change this to 0.18 and 0.35 and 0.5 for the respective layers. And so again, this is a line weight organization that that I like to follow with my parallel drawings. But your instruction might instruct you to do something or follow something different, or you might choose to do a different kind of line weight kind of strategy for this drawing. And so as you do this drawing, you're going to do this for both your exterior and your interior too. And so I'm just going to cut away to what you should see in your final drawing once I do the interior too. Okay, so now that we've assigned all of our line weights to the layers that we designated, and I also made it, went ahead and made a different layer of a line weight for the corrugated decking, because this is essentially just a detail layer. And this is assigned to the lightest line weight. And I'm going to change all these line weights also to be black, except for the detail one for the corrugated decking. Because again, this is like a super dense line configuration, and this is different from all the other different profiles. I'm just going to assign this to be, I guess, light gray or dark gray. Or actually, I'm just going to assign this to light gray, because we're going to use light gray or dark gray just in just a second. So once I finish assigning the colors for these line weights, and again, just as a reminder, this is just the line weight strategy that I subscribe to, and this is in no way definitive of what you can do for your own project. But once we finish assigning these colors and these line weights to the lines that we want to designate, we should also go ahead and denote which section or which cuts we did to get this small portion of the pavilion that we made of, in this case, the Nestle Grow Pavilion by Ken Kuma and the UC Berkeley students. So what I'm going to do is make a hatch, and I'm just going to make this as its own layer. I'll just place it onto the exterior line weight. So I'm just going to make a new layer called hatches. And this is going to be in a dark gray color. And what this is going to tell us is, again, where we took our cuts to make this small portion of the pavilion. So I'm just going to go ahead and type in hatch, and I'm going to make sure that all my layers are unlocked. And what I'm going to do is just select this entire thing. So it's actually, I'm just going to lock the details for now, but I'm just going to select this entire thing. And so what I've selected already is everything that is going to allow me to start making a hatch. So now that I've selected all the curves that I want to start hatching, I'm going to go ahead and select the boundaries that I want to hatch into. So I'm going to make sure that my check mark is to the hatches layer. And I know that for this, I cut towards the further portion of the section cut line, right? This is the exterior portion looking towards this way, if that makes sense. And so I'm just going to keep continuing and just color in the hatches where I took my cut. And this should be the areas that I cut. And remember that I cut both in this direction, and also in the far direction here, but you can't see that because of this angle. So I'm just gonna right click to enable this. And what's gonna pop out is this hatching panel. And so if you haven't had this hatching panel before you did this operation, this usually comes out after when you select a bunch of lines like this. But if you didn't and you see the hatching panel before, you want to press boundary. You want to make the boundary check mark there so that you can just select the areas that you want to hatch, or else it's going to hatch the entire thing, all of your selection for you. So I'm just going to press OK, and I'll do the same for this interior section too. I'm just going to lock this interior layer or this detail layer, and let's go ahead and start hatching the areas that I need to hatch. So again, I'm just going to hatch the parts that have been cut through just for consistency. And you see that there's this error here of once I just clicked that part, everything was just selected. And I think this is because this is not a completely, because this is on the details here. So I'm just going to escape for now. And I guess I need to do this with the details layer on, which might be a bit confusing, especially when you first do this. But again, I'm just going to start by hatching the areas that I've cut through. So the catwalk and these beams are included, and also these beams as well. And also we cut on these vertical portions too. And that should be all. So now that we've created the drawings that we need to create, I'm just going to create a bounding box. And I'm going to set this to the interior layer for now. Actually, I'm going to set this to this make 2D layer. And this is going to have a no print width, because this is just for setup purposes. And I'm just going to make this into an 11 by 17. And we're going to scale this accordingly to the scale that we want to scale it to when we go and print this. So I'm going to make this 11 by 17 or 17 by 11 because this should be landscape. And drag it to where I want it to be dragged to. So the assignment says that you should be printing this at a 30 or 3/4 inch equals 1 foot scale. And I'm just gonna go ahead and start also formatting this as the way you should for best practice. So I'm just gonna also make a new layer called formatting. And when I format my drawings, I usually include my name, my professor's name, the course, and also the term that I'm in, and also the university itself. So this is what it should kind of just look like. I'm just going to set this to the fonts that I usually use, which is this one. And I'm just going to change this to, I don't know, I guess a 1 foot height. So Victor Chung, and then arc 132, and then winter 2022. And then also, you should also add your section number and your professor's name. Let's write professor or studio XX for now. Winter 22 and Cal Poly slow. And I guess this is way too big. And one thing this is the case is because I didn't exactly set my document properties right. And so once you go ahead and do this, you should make sure that your annotation styles, if it responds, are these should not be checked. And so once you press OK, this should be what the actual units are. So this is still a little bit too big. And I'm just going to change this to 0.25. Maybe. And I might go a tad bit smaller, maybe 0.1 or 2, maybe just 2. So And then I'm just going to change this to the bottom right hand portion too. And now I'm just going to lock this just so that I can start moving everything else. And I guess for your Pavilion project, you should also note the name and the scale that you're printing this at. But for now, just for time's sake, I'm just going to start printing. And I'm just going to use the print command. And then you can already see that the drawing is formatted kind of to the language that I want, but I'm just going to start formatting this for real. And I'm just going to go ahead and just use this window setting as I'm sure you're familiar with by now. And I'm just going to set this to the scale that I want it to be. So again, it should be 3/4 equals to 1 foot. And this is what it should look like. I'm just going to go ahead and print this. And we'll take a look at it from there. So this is what my drawing ended up turning out to look like. And you can see that the line weights are differentiating the different surfaces that I have and the different materials that I have. So this corrugation is evident, although it's very light. But that's also because I want to preserve the clarity of this drawing. And the other surfaces are evident too. So this catwalk with its gap between each of the planks are there, and the different members that comprise these beams, for example, are there. And overall, this should be what it should look like to complete at least the nested pavilion, Nest We Grow Pavilion by Kengo Kuma. In this case, the 4th floor meeting the exterior wall. So I hope this helps you in constructing your 3D model of your Pavilion Precedent, and I wish you the best of luck in your assignment for this. And if you have any questions, feel free to ask any of us ISAs and during our office hours, or shoot us an email, and we'll be glad to help you out. Thank you so much. Good luck.